We have talked about spray foam on this channel, and I think that the how exactly we're doing this stuff is very important, which is why I have a very special guest to show you today. This is Michael Dynna from Spray Jones. Michael, thank you very much for joining us today.
Thank you, Corbett, for having me on. It's been a long time coming to meet up and have a good chat on phone and what's going right and what's going wrong.
Yeah, that's right. And so for anybody who is not familiar with Spray Jones' channel, if you want to get really in detail about what exactly goes wrong, the kind of real granular how to do this kind of stuff right, Michael is working in Canada. So that's one difference, and we will talk about that today. But you're going to get a lot of information if you subscribe to that channel. So if you're interested at all, or you think that you might use spray foam down the line, please do make sure that you get that information, because being more educated and informed is super important before you do something that is this invasive and also this fast. So the things that I'd like to
Mm.
talk with you today, Michael, are so we're going to get through 5 major things here. And this is just to let you guys know, if you want to skip ahead to the thing that you're really interested in, go ahead and do it, because like once you get Michael on a roll, he can start to really get into the into the weeds, which is good in a good way. First of all, we're going to look for what to look for or ask for when you're shopping around for a spray foam contractor or looking for specific spray foam. We might get into like product specific stuff. What to prep for before install. So a day before, how do we make sure that we quality control the site? Day of install, what should we do?
Mm.
And this is as the client hiring the contractor. What should we be looking out for on the day of? And how can we help to QC the process? Also then getting into roof applications, closed cell versus open cell in different climates. And then also hybrid applications where people want to do some, a flash and then a bat, or a combined closed cell and open cell to kind of get different things out of it. So let's dive right in and say, I'd like to share first this picture, which is why I got interested in spray foam early on. This was an inspection that I did at a house where somebody didn't know any better, did not subscribe to your channel. This was before your channel existed, and hired this company and paid between 2, 3, 4 times as much as they would have for a bat install. And it ended up looking like this. And that to me is a worse, actually, than the worst fiberglass bat install I've ever seen. And this was where it was like, wow, this is a brilliant product, but if you use it wrong, then we have a major problem. So putting this to the side and knowing that you can do this very wrong is the kind of basis of all that we're going to talk about with Michael today. Michael, uh, what should we be looking for first off, first glance, when we're looking online for somebody to hire locally to at least talk to about maybe beginning this process?
Uh, that's a tough one to answer because I guess the best thing to understand is that the online presence is not necessarily who you're hiring because they can fake it really well. So they can have a good logo, they can have 5-star reviews, they can look and have all their buddies typing in saying, "Yeah, use this guy, he's amazing, hire him immediately." A good look is going to be deceptive. You're going to have to start talking to them. And what you are looking for is somebody that is going to call you back in a timely fashion or email you back. I think if you're chasing them for 4 or 5 days or a week to get a hold of you and get back to you, if they're constantly too busy to talk to you, that's a red flag. Then once you do talk to them, I think that you've got to get a quick grasp on, do they have building envelope understanding? Do they understand their product and how it's to be used, the limitations are? Are they interested in finding out about your project? Like if they're quoting off a square foot number, they're rattling off rates before you've even had your conversation with them on what you're trying to do, that's a red flag. I want to get to know you. Corbett, you're coming to me. You've got a building. Okay, what are you building? Where? Do you have a copy of the plans? Can I get them? When do you plan on building it? What stage are you at? Are you generaling it yourself? Do you have somebody generaling it? Have you used spray foam before? What type of insulation were you thinking about using and why? I'm going to start nailing down these questions to you, right? And as a consumer or the end user, if I'm the spray foam guy asking you those questions, okay, big check mark. But if I'm coming in saying, yeah, 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 not a problem. We're so much a board foot, we'll beat anybody's price by 10%. You bring the quote to me and we'll beat it. Major red flag.
That sounds a lot. I mean, it kind of speaks to the idea that spray foam once you start looking into it and you look at your channel and you look at the few videos that we've had on our channel about kind of problems that have happened, which the point of today is to figure out how can we avoid the problems and still do it
Yep.
right. Because in some cases, you can't avoid doing it. It's just like you can't find anybody to install bats. But if somebody who's installing spray foam doesn't understand what a liability doing it wrong is, that
Yeah.
sounds really scary because, like, a lot of us know that, like, ooh, it's an iffy kind of a thing. So I think that all
Mhm.
of those sound great. Then you have them out to let's say, to the site,
Mhm.
and you
Yeah.
look at the house. Is it typical for you to, when you're doing a site visit, to point out, like, ooh, this area right here, it's going to be hard for me and my crew to be able to do that right. And here's why. If you could fix the framing here, that would be better. Do you do things like that and try and get them to
Oh, you have
change?
to.
Great.
Absolutely. Very few of the builds are purpose built for foam. And foam is not a miracle product. Let's back up for a second because I like where you're going with this. I really do. Okay. We've got a big issue in spray foam installation right now. We've got a elephant in the room that I hope that my new venture that we're doing is going to help put some light to, and that is proper education, so that we can get a proper installation, so that we can maintain a proper reputation. And that all starts with educating, knowing why you're doing what you're doing, knowing what can go wrong. So when you go to site, when you're talking, like we've had people that have said, all right, I've already got this house at framing stage, it's at lockup. Brother-in-law said, why don't you think spray foam? I talked to 2 or 3 guys. Now I'm talking to you. All right. So you're at site, you do a walkthrough. If you can physically do a walkthrough, you need to be explaining to them what you need in order to do your job properly. So blind corners and header areas. Is too much ductwork been installed? Too much plumbing been installed? Was the house purpose built for fiberglass bat, and now you need to go and retrofit and change some things to accommodate spray foam because they're not one to one. Sometimes the advantage to spray closed cell foam, particularly closed cell, not just open cell, is that we have some design changes that we can make that you want to take advantage of. Now, sometimes you can make those changes, sometimes you can't. Sometimes that horse is out of the barn already. So we want to do a walkthrough and say, all right, this needs to be closed in, this needs to be cut out, this needs to be open, this needs to be done, whatever. And I'll give you some examples of that. So a corner where the framing is tight, the next available stud over, you can't rotate the gun and get the spray foam in. So we've had them take a Sawzall and cut that out and then sawtooth it so that we can actually have enough rotational area to then pack that corner full. So that's got to be done ahead of time. And we believe that they should be doing it because spray foam guys shouldn't be ripping out tools and hacking away at framing. And, what are we going to do for damage? Um, Secondly, where one roof meets into another roof and you're spraying to a roof line, you've got to be to the most outer available roof line at all times. So you can't be spraying to a false roof internally, and then there's a second one over top of it. So we get those cut back. Um, they might have installed ductwork and plumbing, HRVs, ERVs, furnaces, water heaters way too close to where we need to be. So we've either got to get them to move it, disconnect it in some situations, or figure out a counter solution. So yeah, doing a walkthrough is incredibly thorough, and we have to speak slowly and intelligently and tell the client and the owner multiple times. And you believe me, Corbett, we get a lot of blowback. Well, why do I need
I
to cut
bet.
that out? Do I really have to? Do I have to get the framer back? Do I really have to change that? Do I do? Oh, can't you
Yeah,
just
the
do this?
two
Can't you
guys who
do
came
that?
before you were here said I didn't have to do any of this stuff, and they were cheaper than you.
Correct. Correct. At which
They didn't
point I
even want to
walk.
have this meeting.
Oh, that's exactly right. At which point it's like, you know what? I've walked. I had one guy that told me how he had built it and wanted us to quote on spraying it. And I said, no, it's built wrong. It shouldn't be sprayed that way. Well, the other guy said that. And I said, no, the other guy's wrong. And here's why. And I've said very frankly on the phone, if you wanted to get involved, you're please going to have to do what I asked, in order to do this right. They didn't. I never heard back from them again. And that's fine. Part of business is learning who you shouldn't be working for. And I mean, spray foam guys
100%.
need to have that attitude. of, if you're not going to do it right, I don't want to be on site, because we don't need to be in another lawsuit with having everybody pointing fingers at us. And it is a real challenge between having the work that you want at a good price, a good rate, and an uncooperative client. There's somewhere in the middle. You got to meet in the middle, because they're very rare are the clients going to do everything that you want them to do. Okay. I've had a few, usually on custom builds. It's our dream home. You tell us what we need done. The guy's coming back, give us a list. It'll be done. They take pictures of it, send it to us. Is this how you want it? Perfect. But then more with track building and main production building, it's like, well, we can't change it. Can we modify it slightly? What can you do? They pay good lip service to doing things right the first time, but they're not. It's about what's in their pocketbook.
And I think that they think, I mean, you told me that you get asked, like, why can't you just use the wand? Like you've
The
got an
wand.
extender to just get back into those
Yeah.
corners. Is
Yeah.
there a wand, Michael?
No, there's no magic wand and there's no practical wand. You're dealing with twin component materials that are mixing at the gun head, 1-to-1 by volume. And so they need to make foam right then and there. So to go through a long extension wand, you'd plug it up on one use, and you'd create enough back pressure that you'd probably blow the wand off the assembly. So no, it's a true spray. Spray formulation is liquid, and think of it just like stippling or painting. You've got to be within 20 inches of what you're doing.
Cool. Okay. So day before, it sounds like we've done a meeting. There, a week before is basically when you're there. They've done some stuff to fix the framing, make sure that everything is the way that you want it. And now, day before, what could I do as your client to make sure that the site is ready for your crew so that everything goes as smooth as possible? The guy who's in the mask, and by
Mm.
the way, for those of you who don't know, the guy who's installing this stuff is wearing a full body Tyvek suit with like a limited view, right? About this, you're seeing about this, like a horse. And they've got oxygen pumped into the back of their, right? So it's not comfortable. Do you still spray yourself for your on your cruise?
No, not
Okay.
unless something's gone a heck of a lot wrong. I got out of that in year two. Let's back up to what needs to be done. I just want to make a strong point. I want to be involved in the build as early as possible. I've
Hmm.
got plans on my desk right now that the houses haven't even started yet. They know they're going full spray foam. So from it's not uncommon for us to be involved 18 months out, a year out, for sure one building season out.
I imagine when you're going over those plans and reviewing them, you're looking a lot for like moisture management layers and flashing and stuff like that. Is that right?
Um, Okay, not entirely. Okay, there's two envelopes going on, right? There's your exterior envelope for moisture, and then there's what are we doing internally. We're always the internal person, generally speaking. So what we're doing is, where can I put the foam? Where do I need to put the foam? So how is it detailed? Do we have cantilevers? Do we have floor sections out over top of garages? What's the basement like? Is it a crawl space? And the builder is generally looking for us to complete their knowledge of envelope, internal envelope. So we're just trying to go through the build, through the plans, and identify what the drawings say to do, because the drawings will have a basic level of thermal recommendations of envelope and what have you. But then we've got to tweak it, where we are really trying to be a specialist, where we're coming in saying, let's do it like this and let's purpose build it and design it for that. And most of the time, if we can make a good argument, Corbett, for why it should be done and what the net benefits will be versus the cost ratio, then they can talk their client into it. It's always going to come down to, well, I'll run it past my client. I'll run it past the client and see if the client wants to pay for that. And if they do, great, then it's in. And if it doesn't, out. We have to figure out who is representing our interests on site. Are we working directly for the homeowner and they have to get everything downstream? Are we working for the builder, or a combination of the two? So we want to start consulting from the framing stage, the blocking, the shingles, the roof, get everybody on board. And if the roofer or the plumber or the electrician or anybody's got any questions, we want them bringing them through the proper channels and getting them addressed. And then if it requires a site follow-up meeting, so be it. And then we usually do a pre-walk through, ready to spray. They think they're ready to spray. We'll do a walkthrough, which is what you just described. And now the day of is where you brought us to. What do you do the day of? You clean the place up. You get the siding, the building materials, the garbage bins, You get the truck so they can get backed right up to the door, the foundation. You don't have a whole bunch of other trades scheduled in. You do not have debris inside. You don't have sawdust inside. You don't have sensitive materials like saws and tools. I had a guy leave his chop saw in the job site. We covered it. It's still got overspray on it. He's like, "Hey, I got $1,200 saw sitting there and I got a little bit of overspray on it." And I said, "Well, why was it still in there? You knew we were coming. You knew." He just didn't want to, he was lazy. He just didn't want to move it. So I said, we covered it. We did the best we can, but them's the breaks, dude. Like that's
Yep.
the break when you leave your gear in where spraying is going to be happening.
And you said
You
not a
want,
lot of other subs on site, but really there should be nobody else in
yeah.
the building,
Uh,
right?
well, you can have the siding guys going outside. You
On
can
the
have some
outside.
people going on the perimeter, but you're right. The general, well, in Canada, we have got isocyanate studies, and being around isocyanates unprotected is a minimum of 10 meters. So that's 30 feet, 33 feet you need to be away. So we've gotten asked this before. If you guys are all the way upstairs on the second level or in the loft, can I have my guys finishing the plumbing in the basement? And the answer is yes. Okay. They are more than 33 feet away, but do they have their trucks parked everywhere? There's stuff strewn all over the place, gear in our way. Are we in theirs? The other thing is there's a perception that foam is just horrible, horrible, horrible. Some trades, even though they're well out of the spray area, they'll just freak out and throw a fit and either not want to do their job right or not want to be there. We've seen that before, especially with plumbers. So there's like, no, if you're on site, they don't want to be there. So it's like, okay, so then we'll tell them, look, get your stuff done, turn the house over to us, the building over to us, let us have at it, don't interfere with us, and we'll be good to go. The other big thing is dry. Like you cannot be going to spray foam, closed cell or open cell foam, and the building is wet. And that also means high humidity, which is going to be a problem down in Georgia, in Atlanta. I mean, you're dealing with 80% relative humidities. When you start to get high water in the air, you're going to run into adhesion problems, just like you would if you're painting, just like if you were doing drywall mud, right? Think of spray foam insulation of any kind as close akin to painting as you can get, as far as surface prep and bonding.
Mm.
So dry and low humidity. And there are no perfect answers. I mean, I was just down at Spray Polyurethane Foam Alliance and I was having drinks and some food with some guys from Tennessee. They're in the Smoky Mountains in there and it's muggy all the time. So they just have to start earlier, get more fans, get things ventilated, pick their days. And this is the diligence of the spray foam people. It's like, okay, are the climatic conditions aligning so that I can actually do my job properly, or do I have to shut it down? And it's tough. There's a lot of days where you have to stop because it won't be conducive to what you need to do.
And you don't make money that day. Just to remind everybody, in most, I think, high performance construction, which is basically most modern construction these days, putting a dehumidifier in the building when you have like dried in, and that's the term we use, dried in, which means no more rain can get in there, but maybe everything is soaking wet when you enclosed it. And so now it's just sitting there and it's not able to dry out anymore. So having a dehumidifier installed during construction, I think super important. I don't know if you guys have them that you take and like put them in there and say, hey, I want this thing to be running for the week until we get here.
It can get to the point where those things can run if it's gotten wet enough. Okay, if the building was going up and getting sopping wet all throughout the various stages of construction, and now it's at somewhat weather tight, the dehumidifier could run for weeks potentially, right? So it's got a long task to try and pull all the humidity. I'm not saying it can't do it. I'm just saying that in the timing of the build, one would have to give it quite a bit of time to equalize. So what we've found is opening it up, getting the air moving through it, windows and doors, fans moving, and try to equalize it. And then you're just going to have to, as a spray foam guy, really, really watch it to make sure that you're within it's sticking and checking it. Now, a good spray foam guy will know that. They will know when their foam is going squirrely on them and something's not right and stop. It's the people that don't know or don't care to know that are causing the problems that you and I are talking about. And let's be frank, I want these problems gone. I am on a mission to highlight what is wrong and give our industry a proper slap upside the head, because we are in danger of creating irreparable harm to our industry that won't allow us to come back from it. And it's just through straight ignorance, brute force and
Yeah.
ignorance.
And just so everybody's clear, this is not a problem of the installers being dumb. Because I was listening to a podcast yesterday about pilots, and they were saying that they call it get there-itis. It used to happen a lot more when pilots could have a lot more autonomy, but they would be like, take risks because it's like, man, I just got to get to my next thing so that I could take the next flight and I gotta like stay on schedule. And that is something that everybody suffers from. So like having some series of checks and balances where you feel either empowered to stop yourself or forced to stop yourself by an employer like Michael, for example, which not a lot of employers are going to encourage their team to like stop work and stop making money at that point. So I think that I agree, this is super touchy. What do you think the solution is on day of for stopping? Like, is there some kind of a third party that comes in and checks in the beginning or in the middle of the day that is the kind of,
Um,
flight controller?
Good question. I think that would be cost prohibitive
Mm,
for everybody, because somebody's going to want $250 a site visit to come out
yep.
and babysit somebody it comes down to you're the builder. I'm working for you. We need to increase your IQ on spray foam. We need you to know what it should and shouldn't be done, how it should and shouldn't be done. And that's why my new channel and my new platform coming out is directly aimed at education for everyone, not just for the spray foam guys. It's for the builders as well. So learn about the foam so that you're not being lied to. And then the installer should be coming out, and they should be somebody that knows and likes their job and has been well trained. Now we're trying to combat that. There are guys that they've thrown them in the gun, get out there, spray it, itis, just get it done, get it sprayed. Uh, those guys are the
Spray it
problems,
at it. Yeah.
But the guys that were at, SPFA was having a huge competition for who could spray the smoothest, and they're giving away some pretty big prizes. Everybody that was in that group that had the foam on their shoes and on their phones loves their job. They got tattoos of spray foam on their. It's a brotherhood, just like welders, just like framers. They take pride in their work, and they're not going to come in and try to push things generally. So the people that are pushing things, it's a builder that doesn't know or doesn't care to know, and then it's a spray foam guy that really hasn't been educated and doesn't know. And I think the implication really is that, okay, how bad could this be? I had no idea it was going to stink forever, or it didn't bond and it let moisture in and it rotted out the walls. Like, just understanding just how bad these problems can be and what can go wrong and the implications, will get a proper dose of fear into people to get them to stop being foolish.
So here's a question that I've got. I thought that the correct way to spray was like basically picture frame it, grab the corners first, and then
Yeah.
do the middle. So first
Yeah,
basic question, does that sound correct?
absolutely.
Because you see on
You'll never
Instagram,
get
there's a
in
lot.
trouble with that.
If you start telling the algorithm that you like spray foam, they'll show you lots and lots of videos of people doing it. And I'm like, I'm pretty sure that guy's doing it wrong. Okay, so second question that's like leading from that. I, as an HVAC designer, love open web trusses. I
Right.
would imagine when somebody talks about doing an open web truss with spray foam, I'm always like, ooh, that sounds really hard. Have you figured out a way to do this well? So, for example, in a roof, if you got a flat roof section, just as an example, everybody can kind of imagine this. Flat roof section, let's say it's a 20 inch, you're going to use the bottom 8 inches for ductwork. And then I want to pack the top 10 inches with spray foam.
Oh
I
yeah.
imagine that getting around all those triangular shaped things where all the wood is kind of going and coming, that sounds
Yeah.
like there's definitely going to be some air bubbles in there in my mind.
100%.
Okay.
100%. That's self-evident. Absolutely. So that is where I like using closed cell foam. All right. So if we're using open cell foam, you can get it to crawl in and around the open webs. You're right. Having a solid web allows you to get it between, but then you're dealing with the solids where you can't get insulation. Open web, all right, you're going to have to be more detailed. And you are right. It can be an air sealing nightmare to be diligent, but that's where you put one pass on, Corbett, of like, if I was doing it in open cell foam, I'd put one pass on, say, 3 inches, and get everything, top cord, connector plates, all the X brackets in. Then I'd come back and continue to build up, and then I'd build up a third time. I'd make probably 3 passes on that to get everything dialed in, and that's how I'd price it. If you're going to try and go in and get it done in one pass, no, you're going to have problems. Now, when you enter in with closed cell foam, You wouldn't need 10 inches. So now you're not necessarily coming as far down into the webs and intervening with that cross sectional. Your top cord is probably going to be on the 1.5 inch dimensional flat, and then we'll just overlap it, and we'll just be kissing up into where the metal connector plates are going to be. And I would be able to give a good detailed spray job on that. In fact, we're going to be doing one here right away for a mall that had a fire, and they had to rip down the poly and all the vapor barrier and all the loose fill insulation. They don't want to put it back up. And that one is going to be 3.5 inch top cords on edge. They're 3.5 inches deep. So we'll put in 4 inches of foam. So we'll come over top of those, and then all the metal connector plates will be embedded in foam because you don't want them dripping, right? Steel is what, 400% more conductive than wood. Yeah. So you want all the metal connector plates embedded in spray foam, and then you want all the X braces to be embedded in foam as well. Now, you're not necessarily trying to get a huge amount of spray foam over the cord. The cord is vertical, and the capillary action of the foam going over it means you just make a big humpy, bumpy, lumpy mess. So we call it, I won't call it oopsie foam, but what we're trying to do is we're trying to build our foam up in the bulk of the middle and get more than just a minor overspray value on the top cord. We're actually going to try to build foam on it, but not to the point where if you measured it with a probe, it would measure out perfectly to the 4 inches that you put in the middle, if that makes sense.
Huh. Why is that? So, I thought you always would want to cover any wood just to make sure that you've got it continuous.
We do cover the wood. The wood is absolutely covered. It's just the amount of extra material that it takes on the capillary action of the foam to try and build over top of vertical surfaces. The other thing is when we have thermographied them out, we haven't found that the wood with lesser amounts of spray foam have tested out drastically worse than where the spray foam is at full thickness. So it just doesn't necessarily constitute the time and effort of material to try and remove a problem that we're not seeing. So in our cold climate, I'll give you an example. It was minus 38 Celsius here this week. Okay, so minus
that's almost the same
Fahrenheit.
As minus 38 Fahrenheit. I'll say
Fahrenheit. All right. So the top cords in the roofs that we do, we can go in and measure them. At 4 inches of closed cell foam, when it was minus 38 Fahrenheit outside, there wasn't a single spot in the roof deck that could be found to be any cooler than 18 degrees Celsius.
Yeah. So how many hours do you have to wait? I use infrared a lot. And I would imagine that you're talking about coming back the next day to look at that. Are you talking about later that afternoon being able to see this stuff?
Yeah, we'll scan it the next day. But this is just the example I'm giving is just taking a building that was sprayed 12 years ago and thermographing it out and just seeing how it's doing. Yeah.
Yep. Totally. Okay, great. And so, for example, then if you're using dimensional lumber, or I-joist for that matter, and you're trying to spray full depth, one of the other things that I saw in my inspections starting in Chicago back in 2008 was that installers would like to say that they want to spray not quite to the depth of the 2x4 because the skin on the spray foam was very important and it's a precious part of it. We don't want to cut that away. I thought it probably sounded like they didn't want to overspray and then cut it off, which is wasteful and also a pain in the butt. But so first of all, in walls, do we spray full depth? Is that the right way to do it, or go just shy so that you don't miss the drywaller's job? And secondly, then, if we're doing a roof, do we want to cover those rafters?
Okay, those are a lot of good questions. What product are we spraying first and foremost? Opener cell or closed cell?
You're the expert.
Okay. Well, all right. So let's talk about open cell for a bit because there's a lot of it sprayed in the United States versus Canada, and that's the reason being is that we're required up here to have vapor barrier. So a lot of people aren't going to want to opt for open cell foam and then still put up 6 mil polyethylene or some type of layer. So they'll just opt to get closed cell foam. So when you're spraying open cell foam, you're trying not to create excess mess. There used to be a mindset that the 2x6s should be 100% flush filled. Now that means you're going to get some hyper anal retentive client that's going to come in there and measure every last single bay and see if it's at all cupping to the inside. If your knife bowed just a little bit, and then get you to respray it because they want every last damn inch that they were supposed to get. So the spray foam industry tried the overfill. So you were overfilling by 20%, shaving it off. Now you got to collect that, mulch it up, bag it, get it out of there. And shaving is a heck of a lot of work. So if you can get into a just filled cavity, it's speed, it's money, it's production. The argument that the skin, it's better with the skin on than the skin off, that's not really what's driving it. Is there an argument that skin on is better than skin off? Yeah, okay, you've got one more extra layer of something to additionally deal with air and water. But no, the real reason is it's faster to get in and out of there. Now, with closed cell foam, we're not wanting to fill it up unless we're being told to. And see, this is the big issue that we have. Okay. Spray foam is expensive enough. And why do we want to get into shaving it down if we don't have to? We always want to have, what I want is at least 1 inch deeper cavity than what we're being asked to put in for foam. And this is the big topic that we're going to be tackling with the Spray Jones YouTube channel, and you've seen it in yours, and it's worthy of its own conversation. It's the whole R value game, and the code book right now is written for fiberglass. It's not written for spray foam. It's not, and the fiberglass industry knows that, and they have got a monopoly. So as long as they can keep the discussion on R value, how many R's did you put in here? How much R value did I get? Can I get the maximum R value? Then the spray foam industry is always reactionary. They're always like, well, we can give you this much R per inch. The problem is we're expensive. Okay. And that's not really the topic of conversation to be having. So maximizing the amount, like very, very thick amounts of spray foam into small, tight spaces is a problem. It creates added cost, added waste, added time to clean it up, added time to shave it. For what gain? Right. And I think we can make a really good argument that if we don't have to shave it, we shouldn't be. So get the dimensional lumber or any choosing of framing to be thicker. That's generally not a problem with roofs. Roofs are going to have more than enough depth to pick up the load and the spans and just the framing. It's when it's down to retrofits on old buildings and walls, and they don't want to bring out the walls any much thicker. So we try to just I try to have 1 inch more than what we need, and
So you're saying,
not
just to
have
be
to shave it
clear,
off.
you're
Yeah,
talking about in a 2x6 cavity, which really is 5.5 inches. You want to only
correct.
spray 4.5 inches. So the builder has got to be
Mm,
okay with R15 of open cell, or if you're going to do closed, you can get R21 with more like three and a half.
I didn't explain that very well. So if
All
I'm
right,
using open cell foam in a 5.5 inch cavity, I'd like to be about 5 inches in a 5.5 inch cavity.
I see.
Okay. Or just kissing up to it, where I just have a few of the high spots to shave off. So I haven't really ripped them off, right? I've given them their money's worth, but I've not put so much in that I've got copious amounts to shave.
Mhm.
Then if I'm going to be doing closed cell foam in a 5.5 inch cavity, I want to be somewhere like 3, or no more than 4 in a 5.5 inch deep cavity. So, but if a client is doing a basement or a crawl space, or they're putting framing out, they've got a sea container home and they want to put framing out. Well, then I don't want to take a 2 5/8 steel stud and try to put 3 inches into that.
Mhm. Yeah. Okay.
That's going to be a lot of shaving and a lot of mess and a lot of extra
Great.
cost.
Yeah. Um, we'll get further into the specifics because one thing that I want to talk with you about is the colors that you've got in
Yep.
Canada, which
Yep.
I was really impressed with. But the other thing that really came up in this first conversation that you and I had outside of this interview was that when I talk about spray foam on my channel, my perspective is fighting against the marketing companies and the marketing power that is trying to be behind a lot of spray foam in the US. When you are coming at this, you're coming at it from a very different place. Will you explain the Canadian history of spray foam briefly?
Briefly, see if I can do that briefly. It was removed in the early 80s. There was no foam insulation being allowed in structures because of urea formaldehyde foam insulation, UFI as it's called. UFI is a totally different chemistry. It wasn't mixing. It wasn't staying dimensionally stable in the walls. It became a liability very quickly. And so it went from being a very popular retrofit product to overnight, it was a nightmare. And you couldn't get a mortgage with it. You had to sign a declaration that there was no UFI in the home. So UFI was being removed. At that time, the spray polyurethane foam industry walked in and said, hey, wait a second. We're not the same chemistry. We're not installed the same way. We're not pumping it into the walls. We're spraying it into the walls. And they said, all right, fine. You want to get in the building code, then you're going to need to have third-party standards, agree on what kind of foam, what density, what physical properties it's going to have, what the mix should be, how it should be mixed, what the equipment are. So there's going to be a certification and verification of the manufacturers, and then you're going to mate a certified product to a certified installer. So the certification process at that time was a minimum of 2,000 hours of previous spray foam experience. So there was no getting into this cold turkey. There was no going to buy a rig and just deciding to do it. You had to apprentice. You had to go to work for somebody, and 2,000 hours translated into just about 2 years, 18 months kind of thing, a little bit longer than 18 months. And so the industry had it set up fairly well where, okay, there was third-party standards. In the United States, you use UL and ASTM. Well, we use ASTM. Just in Canada, we use ULC. That's a Canadian version of UL. So they're testing fire, smoke development, adhesion, water absorption, everything that you would ever want to know, about 20 different things. Then they wrote that standard right into the building code and said, all right, any building that the code has jurisdiction, so not an agricultural building, not a mobile structure that generally doesn't meet national building code. So a residence that's tied to a physical address must have, if you're going to use foam insulation, it was written into the building code 1990. Well, 85 was the first time they wrote it in, but 1990 is when they had specific line texts and said, all right, you're putting spray foam insulation. We will recognize it as an insulation, but you have to meet these standards, right? If you meet the standard, then that foam can be installed. That foam has to be readily identifiable by sight, because otherwise, how are you going to know it? They're all going to be nut buttery color, white creamy colors. They all look like that. That's the natural color of polymers. Polymers are synthetic oils, right? So they had to dye it, and it had to be readily identifiable by sight so that each supplier was no two were the same in color, and that the building inspector could walk onto site and say, oh, purple, okay, that's BSF wall tight. Oh, green, that's Huntsman, that's heat lock, right? And so on and so forth. Why the US is not doing that is beyond me. That's the conversation I keep having when I was at SPFE. You guys should be dyeing the foam. You should be dyeing the foam. You're missing a marketing bonanza on trademarking and dyeing your foam. And then you have to be a certified installer spraying a certified product. Now, before we start bragging about our certifications, you can be bad mechanic, bad cop, bad lawyer, bad accountant, bad builder, bad roofer, bad spray foam guy. Okay. It's in here. It's the heart and the mind of the individual, right? You can be a bad HVAC guy. So just because you took a course and you got your card and you went through your hours doesn't mean that you are going to do your diligence out on site. You should. It's supposed to mean something. But how does one inspire you to excellence out in the field when no one's looking? Where does integrity and value and virtue come from? And that's why I'm aiming to change this a bit with our new platform, is to get an attitude and a culture of excellence, and to really shine a light on what can go wrong so that people will feel ashamed and stupid and not want to do the dumb thing, all right, and do the right thing and be celebrated for it in the community.
You and I do this for the same reason. We do our jobs for basically the same thing, which is we just get pissed off when people do things badly.
And
So
Corbett, the foam deserves a slagging. Okay. When I first saw your channel, I was like, this guy hates spray foam. Okay. Because everybody was sending it to me and they're like, see this, see this. And then I was like, he's actually right on a lot of points. Like, is he wrong? No, he's not wrong. Right. We deserve a beat up on a lot of things because we're saying wrong things. We're doing wrong things. We're not, no, don't do it that way. But there's no unified voice to try and coach the conversation. as to why you shouldn't be doing it. So yeah, we deserve a beat up on a lot of cases. And I'm trying to get the word out there on some of the things. Yeah, we've made mistakes too. We're not like Mike is not the guru of spray foam. I am not. Okay. I'm just this outspoken guy that has a knack for saying it the way that it is. That's all.
Absolutely. And so just to reiterate for everybody, you can see a lot more specifically, like you just watch any one of Michael's videos and you'll see like a lot of things that we haven't talked about on this video. So just to wrap up that conversation about the US Canada difference.
Mm-hmm.
And by the way, I think that we need you. US needs you more than it sounds like Canada even needs you. It sounds like you're trying to push since spray foam has been so regulated and it's had a really hard time in Canada getting to be as respected as other insulation methods. But here in an unregulated environment
Oh
in the
yeah.
US, it sounds like it's
Oh
just
yeah.
like everybody just whatever they want, and it sounds like we just need you real bad. So would you characterize the US as kind of Wild West, kind of like
It
cowboy
is
style?
Wild West. That's what we
Yeah.
say all the time. It's Wild West.
Okay.
It's wide open. So the spray foam guys that are in the biz right now, the good ones, like I was meeting with people from Wisconsin and Illinois and everything. There was all states were being represented, some more than others because more are just foam friendly. A lot from the Mid East as well, Tennessee and what have you. But they all are in favor of more regulation. They are. They're in favor because they've seen the guy pop up in their neighborhood in their zip code and like, oh, you're in business now? What makes you qualified? You know, you wrote crayon on the side of your truck with your phone number to call you, and now you're telling the guy that you're going to beat our price. We've got a real serious problem. Like, we do need to have certification throughout all of the industry, like Canada and the US. But also, there's got to be more information given to the building inspectors and the
Mm.
building community because they're letting a lot of this stuff slide. They need to partner up with us as well and get educated and call it out. So we need people like yourself, HVAC guys, building consultants, and then we need an education level at the grassroots of permit. Now, if permit would get serious about having engineered details, you can't just go and put this spray foam to the roof unless you've got the engineering behind it to prove. Who says you can do what you say you can do? Who says? That ends the marketing problem,
Mm.
right? Now, I agree in marketing, and I agree there's a whole nother conversation that we need to have that the rule book isn't written for us. It's not. And there are direct efforts going on right now that we are going to get a dedicated code book for spray foam. We will. And that's going to have some major implications national, like across the United States and Canada, because we won't have to fight on the R value game anymore. It will not be, well, I could get this or I could get that. It'll just be a flat prescriptive recommendation of how many inches of a certain type of foam, open cell,
Hmm.
closed cell.
Yeah.
That's where we
And
want to go.
can I just let me just digress for because I think that a lot of our
Yeah, go
audience
ahead.
might not be familiar. So R value is a
Yeah.
test that is North America centric. This is not how they do it in Europe. R value test is you take a sandwich of this thing and then you put heat on one side of it. Has nothing to do with like it's so limited. I'll do a separate video about it. But in Europe, what they do is they test what the actual insulation value is performed by putting a sensor on each side, and they measure the outside temperature, they measure the inside temperature of a building that's built. And then they say, okay, here's what's inside of that. And so based on what this is doing in real life, here's what we're going to assign to that. And I think that that way is like obviously better. There, you would have to have different regulations and different, the whole system is different over there. So I think that,
Well, let's the R value, you are absolutely right to inject and just build on what you're saying. Do you realize that in the United States, they are just coming to the realization that air leakage has a major effect on an insulation's ability to resist heat transfer? They're just coming to this now.
mm,
So, in the 70 years that fiberglass insulation, and I mean, I don't mean to go down a rabbit trail, but fiberglass insulation wrote the rules by which they're held and judged by. They wrote them. They wrote the test standards. Now, in all fairness, being fair to them, who else was going to do it? You have a product, you need to measure how well it and come up with a way of grading it so that the consumer can understand what they're buying. They need to rate it. Is it a 2, a 3, a 4, a 5? What am I buying? The issue is that when they did those tests, they stopped at one mechanism of heat loss. We've got convective, conductive, and radiant, and they're only measuring one. That's where the resistance value comes from. It's a conductivity test. And we can get into how exactly it's done. Not here, we won't. The point being is that this is now 2025, and we are using typewriter technology in measuring how an installation works to write our codes in an iPad world. Now, it only favors the glass industry the most because they have the most to lose, because the prescriptive requirements are just straight up hit this value, boom, boom, boom. Well, okay, what happens? Do we have to hit that value when we don't let air go through it? Legitimate question. How about when we don't let water go through it? How about when we're bonded to the building material? Right? Because your products lay up against it. There is a loss value when you're not in tight, intimate contact with the substrate. Okay, so these are the
Intimate
things that we're
contact.
trying to get conversation going. But you realize that the fiberglass industry is spending millions upon millions of dollars in lobbying in Washington, and we are a mere pittance of lobbying. So what's going on is when I just learned this week. Okay, the energy codes are the only mandatory government legislation on building. Like people could put no insulation in unless the government told them that they had to, right? The government is telling them you have to insulate, and you have to insulate to a minimum of this standard. But if they didn't have that standard, people could insulate with nothing, right? Nobody's mandating you necessarily to put in extra plugs, electrical plugs, but they are doing this with insulation. So the people that are at the table talking in Washington is the fibrous industry. They make sure that the rules are written for them, and they're not taking account for fiberglass for foam boards and rigid styrenes, right? And insulated concrete. Like the rigid insulation market is really not sitting there having their thoughts heard and their product evaluated. When 1 inch of beadboard is going to get the same quote R value as 1 inch of glass fiber, but you and I both know they're going to behave entirely different in the real world on site. That's what we're talking about. We're talking about real world performance values versus theoretical lab values, and then writing the codes and writing the recommendations based on white paper target prescriptive requirements versus actual. And what the spray foam industry is wanting to do is get the first ever code book written for, if you're using fiberglass, use this. But if you're using spray foam, here's your recommendations over here. And that will be a massive game changer. And I hope to see it in my lifetime before I retire. I'm 47 years old, and I'd like to see that changed, because it will clear up all of this. Well, 3 inches of spray foam is actually an R40. You ever heard that one before?
Yep.
It's not.
Right.
But
So
it
and
performs like
this
one.
is where equivalent R value comes in. But before we leave that topic, I just want to say also, you keep bringing up fiberglass, and I think that we also need to be smacking the fiberglass installers, because when it says R19 required, and then it's like, okay, I'm going to put this bat that says R19 on it, but I'm going to put it in crappy. Like in the manner that I'm putting it in is terrible. It doesn't perform as R19. So that, by the way, just for those of you who have watched some of Matt Reisinger's videos or my videos, when we talk about mineral wool insulation, that's why we like mineral wool, is because it's a lot more idiot proof. Like it's really hard to install something that's denser in a cavity and mess it up when you're using something like that. So there's lots of ways to mess up the other insulation types too. And I just want to make sure that make that point, because like those guys, just because they make the rules doesn't necessarily mean that they're following them.
No,
So
that's right. I mean, it's a huge market. You're talking, what you just talked about is a $35 billion a year market.
mm,
Okay. Spray foam is barely past the 1 billion mark. We're only 10% of the market share right now in North America. 10%, that's
wow,
it.
that's very interesting. It's a lot louder. It sounds louder. So I'd like to, we're going a little long, and I hope that everybody enjoys this super nerd out. But two things that I wanted to get to: roof applications, and I've specifically been asked by several
Oh,
people
yes.
in our Patreon group to ask you about roof assemblies in humid climates. I've got a Raleigh, North Carolina, and I've got a Jacksonville, Florida, and they both, one of them is talking about open cell, one of them is talking about closed cell. And so just wanted to kind of ask your take on that. And they're like typical American construction. Are you pretty familiar with like OSB, roof sheathing,
Yep.
whatever minimal?
What's the question pertaining? Both of those climates are similar to each other. They'd be
Yeah.
dealing with an external vapor barrier versus an internal vapor barrier. What direction do they want to go? Because it's pretty wide open.
So I think the if you listen to people like me who are non-spray foam installer experts, we would generally say, I either prefer closed cell or I prefer open cell for this reason. If there's ever a
Ah,
leak, then closed cell
okay.
will not let the leak through and it's going to have it just sit inside the wood and the wood will then rot. And this closed cell will still stay, but the whole house will rot instead, which is like an overgeneralization. But the
Yeah.
open cell would let the water through, not like it's going to show you where the leak is, but at least it would like show you that there is a leak.
Mm-hmm.
So then it becomes this weird conversation where people insist on
Mm-hmm.
using asphalt shingle roofs with nail guns, and some of those nails will be overdriven. I
Yeah.
assume if it's not a standing seam hidden fastener roof, metal roof, that there will be a leak sometime. And at that point, it's like, I don't know what to tell them. Open cell spray foam,
Mm.
closed cell spray foam.
Okay. All right. Great question. There are pros and cons to each. Open cell foam is not as safe as one thinks. Okay. The reason being is this. You have reservoir capacity with the open cells. What is open cell? These cells are interconnected. Now, does that mean that you absolutely can push air from one side of the foam to the next? No. It just means that the percentage of interconnecting cells is high enough that it cannot be designated closed. Closed means they are shut and they can't get water cannot get from one end to the next. Open, it can weave its way through. So think of it more like you've bought a sponge, okay, versus a non-sponge, right? When you put open cell foam to the underside of the roof deck, you are assuming that the leak will come through fairly quickly and you'll be able to find it. You're assuming that. Where I'm saying that a small leak to the underside of the roof can now wick into the open cell foam, and it has the ability to hold that water reservoir capacity for a lot longer before needing to let it go. It's not an absolute perfect thing. So I have seen roofs that have been open cell foamed, and I'm not trying to draw fear. This is just experience. I've had people send me the pictures out of the US where they rotted out the roof deck as well with open cell because they had a leak, didn't know what was going on, and it only got really, really bad. And that's when they finally knew it. But by then, it had done an immense amount of damage to the upper sheeting, the upper top cords, and the foam itself was destroyed. So do not be deceived. Open cell foam is not the silver magic bullet. When you are putting foam insulation to the underside of the roof deck, the single most important thing going on in that situation is the outside envelope. So I believe in Matt Reisinger's theology on this. I think we should have triple layer protection, and the roof deck should be 100% waterproof before the final building material is up. So what does that look like? Choosing better roofing materials, standing seam if you can have it, going away from asphalt shingles to fiberglass shingles, having a very reputable, well-knowledged roofing installer that's going to do it to a high grade level, having a vapor open diffusion membrane like VP 100 or some of the ice and water shield that has self-healing capabilities.
On the roof surface.
Yeah. So sorry, I'm working backwards now. I've gone from shingle or roof to underneath having an underlay, and then I would like to even see zip sheathing with the joints taped. Get away from OSB for sure. Go to plywood, and even one step better is to go to zip Huber wall system zip sheathing and have the joints taped. They've got a coating. Then okay, did it get past my outer layer? All right. Then did it get past the peel and stick or the self-adhering membrane or the membrane that's got vapor open diffusion? And then finally, do we have a product that when water comes in contact with it, it doesn't immediately go to mush? Those are your 3 layers of protection. At that point, I would be putting either closed or open cell foam, and I'd have a reasonable expectation that I've got a longevity, multi-generational product at that point. Okay. Now, let's address the UK thing here for a second, because I'm going to have experts coming on my YouTube channel from the UK and from the US to answer that. The UK builds entirely different than we do. They do not have HVAC systems in the houses. So they're not controlling the interior level of humidity. All right, that's the first major problem. Secondly, in ultra high humidity environments where you've got damp inside, you got cold outside, you got a cold, wet, foggy England weather or New England weather. Okay, you need to have an internal vapor barrier. They're not doing that. And then they've got slate that's on top of timbers. They're not even putting sheathing, and they're not putting any underlays. And these buildings are 150 to 200 years old. So the issue that went on over in the UK is that they were not verifying if the roof was technically sound to begin with. And it was all being run off rebates. Rebates pushed the sales culture. Get in, get the sale, get the money, get the commission, get on. Well, should they have had spray foam? Should you have even sprayed that job? Oh, the hell with that. Like, let's just get the thing sprayed and collect the money, right? The problem is people were going in with get it done itis. Just get it done. And so they sprayed it, and it was having problems. It was holding the water. It was going to cause, there's that reservoir capacity. It was causing rot. And the industry had a knee-jerk reaction because they didn't take the time to analyze specifically what was going on. They just walked in and said, let's generalize. Oh, screw this. You can't put foam in here anymore. Oh, yeah, I'm not going to insure it because I don't want to eat the cost on this. And I don't want to be stuck with the house, so I won't lend. So you got a lending industry and an underwriting industry that had a knee-jerk reaction when it's like, whoa, wait a second. We can
It
actually figure
sounds
out
like
what went wrong.
it sounds like it was all open cell then, based on what
A
you're
lot of
describing.
open cell.
Okay.
A lot.
Interesting.
And without external water protection, you're talking about a single layer of protection. Matt Reisinger's talked about this before. You know this very, very well, Corbett. How dangerous is dealing with a single layer of moisture protection? Like, you're guaranteed to have a failure, right? So my question to the industry is then this. People say, oh, Mike, you can't be putting spray foam on the underside of the roof deck. You're just trying to screw the inch. I'm not. Okay. We have a technical advantage of putting foam to the underside of the roof deck. That's a whole nother subtopic. We do this. We've got Alabama. We have got Carolinas. We have got, let's go Florida. Florida, if the underwriters back out of the state of Florida, so if if Farmers Insurance doesn't want to underwrite the homes, there is legislation within the state of Florida that Florida has to pick up the difference on the insurance. So in Florida, the state of Florida has to make up the difference and underwrite what the larger companies won't. They are looking right now, the state of Florida is looking for anything that will add resiliency, longevity, and lower energy consumption. So what have they turned to? The spray foam industry to give lower insurance premiums through the state on spray foam to the underside of the roof deck. And here's why. HVAC is being run through the attic, as you well know, that's an advantage, right? And they're looking for hurricane resiliency. Okay. And also now we add a third, which is California. They're interested now in spray foam non-vented to the roof decks for fire. Vented soffits and flame coming up into the vented soffits. So I'm telling you, as an industry, this isn't going to go away. Like, the UK scare is going to be battled with education. And then we will get people to understand what's really going on there. But the spray foam non-vented roof details are going to grow state by state because more and more states are going to want to back them for the things I've just said: resiliency, fire, longevity, all of these energy efficiency, and they're letting them have lower mandatory values because they recognize that when we have an airtight assembly, they call it a foam dome. We have a foam dome over top of the house, and we've got the HVAC equipment in there. We're a higher level of efficiency, higher level of resiliency, fire protection, win-win-win. The insurance rates can come down, and this is something we want to get behind. And that was being discussed at SPFA last week.
Nice. Okay. And by the way, so there's like I keep having these questions that I'm like, well, I want to take the conversation here. We're already an hour into this conversation. But some
Sorry,
of the
I should
things,
just shut up.
No. This is like what happens when we're going to get together. So we'll do this again. But when you talk about flame spread, I think intumescent coating and flame test for foam, which is a whole other topic, which I think can be like, we could talk a lot more about all that stuff. And I think it's important. Um, we have not hit hybrid applications at all. Do you have any little like tidbits to offer anybody for hybrids if they're thinking of like a flash and bat kind of a thing?
Stay
Or do
away
you,
from it.
oh, great. Okay. How come?
Okay. You are begging a lawsuit. First of all, who says you can do it? So, uh, okay. When you are in cold weather climate, this is not what's good for the goose is good for the gander. So, Minnesota, Michigan, North and South Dakota, Iowa, on and on and on, everywhere where it's going to be cold. You go on flash and bat and you put on a thin amount of foam. Here's a couple of reasons that are we have a problem. One, if you're going to go foam at an inch or less, you run into problems. One, you on a practical level, you don't embed all the screws in the nails in foam, sticking through the siding. You're going to
Mm,
have sheeting that doesn't have like the stucco, the lath, the screws. So if the screw's sticking through an inch and a half, and you put on 1 inch, you got a half an inch of metal sticking through. You're going to have a frost ball on that thing when it comes cold outside because you got a direct conduit to outside to inside when it gets really, really cold out, like when it gets down to, minus 17 Fahrenheit. So I got this guy from Pittsburgh. This is coming up in the next video that I'm going to launch. He calls and leaves me a message. They go and they put Roxol up, and the thing's dripping. The house is dripping. They haven't even finished putting the drywall up. And there's like, let's convert it over to foam. Uh, and I had another guy that had flashed it 2 inches, put an R38 bat in. This is in the state of Maine. Felt their hand up inside behind the Roxol bat, and it was wet.
yep.
And why is it wet? It's wet because what's happening is you're lowering the surface temperature of the spray foam. You are not stopping the air leakage from going through. So the air carrying water in the form of relative humidity is coming in contact with now a cool surface of spray foam. Spray foam is not a perfect magic product. It's just a physical product. It's a tool in a toolbox. So if you lower the surface temperature of the foam, you can get condensation on it. You are cooling down the face of the foam. You're putting too much insulation that's permeable in front of it. The air and the water can go through it. That air and water can come in contact with the surface that's now cool enough to condense on, and you get water at the intersectionality. So where the bat and the foam meet. So now the bat can soak that water up. And why are we doing this in the first place? Cheap. We're just trying to make up the distance on our value to satisfy a code book. So if we'd gone 100% closed cell foam, we wouldn't be having the problem.
Yeah.
So that's what they're trying to avoid. Flash and bat gives a perfect host environment to allow this to happen in the colder states.
Interesting. So, and I think that I agree that in general, the how exactly are you going to do this? For those of you who are watching, it's just a little bit too touchy. Every single cavity has to be exactly the right ratio of flash to bat. And also, by the way, the one other thing that spray foam solves here, which is why a lot of people, when they're doing a roof line, and if you've got a complicated roof design, you're going to be stuck with spray foam, period, because nobody's going to be willing to like spend all the time to put bats in there in the first place, even if it is flashed first. But if you're going to do bats, even in a simple roof design, you got to do one of two things. Either have a vapor diffusion port at the top, which you can see on Matt Reisinger's channel, just search vapor diffusion port, or you can do what I do, which is add an underside membrane that takes material and time, and you're sealing it up there, and you're taping it, and you're stapling it to the underside of the roof rafters behind the drywall. So there's extra work that needs to happen in all this stuff, and I do agree that there are some magical things that the tool in the toolbox that is spray foam can offer. So I think if we can just get everybody on the same page with the information that you've got on your channel, on your new educational platform, and get everybody smarter about all this stuff, everybody in the process, that we could all kind of like have this thing work well, where every install is a lot better. It's that airline analogy is not far off, because I feel like we're at the stage where we're starting to get more control and regulation, get these aircraft controllers, get more licensing and certification. But to your point, you could still do it wrong. So thank you very much for all the work that you continue to do on your YouTube channel and on your the houses for your clients.
You're welcome. Thanks for having me on. We just want to
Of
get the
course.
education out there so that we demystify why these things are happening.
Yep, absolutely.
It's not complicated.
Cool. Well, we will do this again. You guys make sure that you comment below if you have other things that you want to ask on the next one, or other experiences to add to it. Go over, subscribe to Spray Jones on YouTube. Tune in next time.